Hello and welcome to this online video lecture for Advanced Goal. Let's see, this is going to, where are we at now? This is 5, 6. So this is going to be 6, 5. Advanced Goal 6, 5. And Advanced Goal 6, 5 is that you understand concentration well enough that you can do math and convert back and forth between concentration, volume, and number of moles. So when we're all done with this lecture, you should understand the concept of concentration, what it is, and you should be able to take concentration, mole, and volume measurements and solve problems to find one of those three if you don't know it. So make sure that you can do that before you try the advanced quiz. So here we go. Let's get into this. So as you may have guessed by that little description, concentration is the relationship in a solution between the volume of solution that you have and the moles of what's called the solute inside of that solution. All solutions are made up of two parts. So if you imagine like a glass, maybe it's got water inside of it, um, right? And then you come over to the glass and you pour some Kool-Aid in there, right? So you're going to pour some Kool-Aid into the water, and of course, when you pour the Kool-Aid in the water, the Kool-Aid dissolves in the water turns red and delicious, and then you can drink it. Well, there's always two parts to a solution. The part that does the dissolving, in this case the water, is called the solvent. And then the thing that's getting dissolved, in this case the Kool-Aid, is called the solute. And that's usually the word that most students are much less, oh, my dog barking at something. That's usually the word that students are much less familiar with, is solute. But the solute is what is getting dissolved. It's not always a solid, but oftentimes it is. And it's what's getting dissolved inside of the solvent. So concentration has to do with the amount of solute that is inside a certain volume of solution. So the solution is the thing that's made when the solute is done dissolving in the solvent. So then that mixture is called a solution. And the concentration is actually the relationship between the volume of solution and the moles of solute that are in that solution. And there are a whole bunch of different ways to measure concentration. I mean, you can use all types of different units to measure amount of solute. There's mass. You can use grams. You can use moles. You could try to count the particles. There's all sorts of different things that you can use. In chemistry, I found that the by far the most common way to measure concentration is a unit called molarity. Molarity. And molarity. Wow, she's just going bananas. Okay, I've shut the door and checked it out, and everything seems to be okay. Hopefully, she won't be bothering us that much anymore. So let's see, where are we at? Molarity. Yeah, okay. So molarity it's got the word mole in it, so you have to figure that it's going to have something to do with moles. But basically, what it is, it's the number of moles per liter of solute. That's called molarity. That's what it's equal to. It's moles per liter. Moles of solute per liter. Moles of solute per liter. So the unit for molarity then, let me pull this back up. If it's number of moles per liter, the unit for molarity, as you would expect, is moles per liter. Moles per liter. Most of the time in chemistry, molarity is it's I would say it's probably the most common concentration that you're going to run across in high school chemistry, or maybe a freshman level college class. There are other types of concentration. One of them is called molality. We're not going to get into that in this course, but it's out there. So if you see it, don't get don't get too surprised. But we only care about this one. So since it's number of moles per liter of solute, the formula, I mean, the unit, it basically is the formula. So in chemistry, we use a large capital M for molarity. It's equal to the moles of solute divided by liter of solution. So that's the formula that we're going to be using. Basically, I mean, now that you see the formula, some of you might be able to just turn this video off and get all your problems right once you know that, because you can resolve formulas now. You can just resolve it for whatever you want, right? Um, But for those of you who need a little bit more, once you know that molarity is the number of moles of solute divided by the volume of solution, you can resolve that. So this is what formula you're going to use if you know the moles and the liters. Well, what if you, let's say you know the molarity and the moles and you want to find the volume of the solution? That gets a little bit more tricky because liters is on the bottom of that fraction, right? But if you resolve it, you can get that liters is equal to moles divided by molarity. And then, well, what if you know molarity and you know the molarity of the solution, the volume? This is actually this is probably the most common case. You know the concentration, the molarity of the solution, and you know the volume that you've poured out, and you want to know how many moles of solute are in there. Well, so you know the moles and the liters, and you want to find the molarity in the liters, and you want to find the moles. So the moles, oh my gosh, what am I doing? Geez, Mr. Hitzman, come on. So the moles are equal to the molarity times the volume in liters. So those are the three versions of this formula you're going to be using. Basically, these are just kind of plug and chug. If you just remember the one I've boxed in blue and you can resolve your formulas on the fly, you know, then it's just one less thing you have to remember, which is always good. But once you have these three versions, you should be able to convert back and forth between the concentration, the volume, or the number of moles in a certain amount of a solution that you've got. So thanks for watching. As always, if you've got questions, please feel free to ask them in class.